Hey, good morning, good afternoon, wherever you are in your day. Start with why. Dive right in. It's Friday night, 4:21. I'm recording some videos, so it might be a little short, but we'll address it. This is where we're going. The why is this is basically the pool problem done on paper. And I know not everybody got there, but there's the application of real world stuff. How long does it take to fill something up? And before we get to volume, we got to start with area. Area to volume to the real world. And we might look again at the volume problem. And I'll just fill it up at home or something like that and record it and get you the data that way instead of going live. It's probably a better idea anyway, but anyway, I digress. So area, volume, real world. Alright, so here's how I think about area of a cylinder. You all have seen a soup can or some kind of can. We get beans a lot and chickpeas to make the hummus. So you got some can. Probably got one right here. Boom, looky here. Alright, so you get a nice tuna fish can here. That's my stash of food. So to find the area of, this is a cylinder, okay, to find the area of the cylinder, we're going to find the lateral area. And the lateral area is the side without the bases. So really the lateral area, how I think about that is just this. It's just this, right? There's the lateral area. Okay, there's the other piece. So the lateral area is the side around the outside. And to get this lateral area, we need to get the circumference, which is all the way around, and we got to multiply it by the height. Okay, so that's really probably the best way I could show that. So lateral area is the circumference times the height. Okay, this wrapper goes all the way around. That's the circumference. Around. And the height is just the height of the can. So that's lateral area. So to get total area, we're going to take lateral area plus the bases. Okay, so there you go. Got a nice tuna can there. Lateral area. Get the bases right there. Okay. Think of the wrapper as the lateral area. Okay. Get into some nuts and bolts. Let's get into some plug and chug, as Vlad likes to say here. Alright, so the first three are really just kind of manipulation problem. You don't need to do much other than lateral area, circumference times height. So if I was doing this, I might LA is circumference times height. It's just plug and chug. 22 is the circumference. Height is 14. That's it. I think the worksheet's just trying to build that skill. But if you have it conceptually, you don't need to really worry about the algorithm. I got 308. Alright, so all those are just more manipulation problems. Lateral area here. So again, I'm going to think about this as, it's a wrapper. It's a wrapper going all the way around. So I got to find the circumference, and I got to find the height. And circumference, to backpedal, I don't know if you guys remember this or not, but circumference is diameter times pi, or twice the radius times pi, because twice the radius is the diameter. So either way you think about it, it's all good. So the circumference here is 5 times 2 times pi. And the sheet says use 3.14. I don't like to do that because the calculator's got a better approximation than that, and it's only one button. So it's easier to type in and it's more accurate. So I'm going to use that. And then the height is 8. Just plug and chug. 10 times pi times 8, or 80 pi. I got 251.2 centimeter squared. Okay. So here go to total area. So now it's lateral area plus the base area. Alright, so we got the wrapper, lateral area right here, and then we got the area of the bases, and there are how many bases? 2. So let's get the lateral area here first. So the lateral area is circumference times height, and I'll worry about base area later. Circumference is twice the radius. That's pi. Height is 7. Radius is 3. 2 times 3 times pi times 7. Boom, 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 boom. We get that pretty quick on our calculator. Base area, and there are 2 bases, so we'll find that. Area of a circle. Some of us got to this in the pool problem. Some of us didn't. Pi r squared. Radius is 3. Pi 3 squared. Pi times 9, or 9 pi. I'm gonna add those together. I just throw that all in my machine, in my calculator. Forgot one thing. There are how many of the bases? 2. So I just throw that all in. I'd probably put parentheses around here because I worry about the order of operations. It might work the other way, but I would definitely separate those 2 for PEMDAS. Times 3 times pi times 7 plus pi times, I'll just do that in my head, 9 times 2 is 18. I got 188.4 meters squared. Checks. Okay, let's hit a couple more for you. That's the same problem. This one's a little bit different. Total area. Okay, same story. Lateral area plus base area, and there's 2 of them. Lateral area is circumference times height. Base area is pi r squared. 2 of them. Again, I'll just worry about one thing at a time. Lateral area, circumference times height. I'm going to use diameter this time. So 70 is the diameter, 70 pi times height. And the height is, hey, it's Fitty. Sorry, subject you to that. No, I'm not really sorry, but there you go. So that's that guy right there. Over here, the radius is that cut in half. I believe that's 35. I'm going to add those 2. I'll just throw it right in, and again separate it with one of these guys. Parentheses 70 pi times 50, close it, add it, open it, 35 squared pi times 2. 18629.47. See what survey says. Yeah, the survey has it rounded to 700, but they used a different approximation, so that works for me. So I'm just going to put that in there. There's the rest of that if you need to see it. 18692, 692.47 meters squared. Okay. And last but not least, let's jump down here. If I ever need to pause this, you just hold your hand up and we'll get the operator to pause it so you guys can get caught up. This is the second time I've done this in like 5 minutes, so I might be a little quick. Alright, lateral area is 288 pi. We need to find the radius. So lateral area is circumference times the height. So I'm just going to plug in what I know. 288 pi equals circumference times 19.2. That's the height. So that's multiply. So go in rule of algebra. Opposite operation, hunt zeros and ones. If you do it to one side, you do it to the other. Boom, 288. I'm going to leave the pi alone, so I'm just going to go 288 divided by 19.2. And I get 15 pi. I'm going to leave the pi because it's a exact number and I don't have to do any math or rounding with it. I just let it sit. Okay, I'm going to change circumference into, I need to get radius, so I'm going to go 2r pi. I'll rewrite it so it's a little cleaner. Okay, that's what we have. We substituted 2r pi in for c. More golden rule of algebra stuff. Divide by pi, that's gone, divide by 2, 15 over 2 is r. R is 7.5. And it's linear, so it's just 7.5 centimeters. Okay, that's all she wrote. You guys are going to work on the rest of this. You'll go silent solo, you'll go in a group. We'll eventually share it out. Hope this makes sense. Keep addressing it. Test on Friday it's looking like, but we'll see where we get. Hope you're well. Thanks for your time. Take care.